So welcome back. All right, we are now on page number 102. Let's switch up colors just for fun. All right, this is page number 102 from your notes book. All right, so let's get started. And in this page, we are going to look at naming and writing formulas using the stock system, which is going to include our Roman numerals. So it's going to be a little bit more challenging than some of the other ones we've done. If you can do these, I feel like you can do any of those, any of the rest. Okay. So the Roman system or the stock system, right, is if we have elements that have multiple positive oxidation states, right? This is going to be our transition metals on the periodic table, which again is between groups 3 and 12 on the periodic table. And so they're going to have more than one charge. And so we are going to either be given the charge as a Roman numeral, or we're going to have to figure out the charge based on the negative charge that we're given in a formula. So again, let's go through here. The cation, right, always keeps its name. The Roman numeral is going to be the charge of the cation. It will not be the subscript of the cation or the metal. And then cations that have a positive 1 oxidation state do not have a Roman numeral in the name. All right, so Roman numerals are only in the chemical name and not in the chemical formula. Okay, so let's get started. So our first example is we have nickel. And then I have oxygen. So I'm going to then change its last name to oxide, right? So then oxygen becomes oxide. So then I do know we're going to all have Roman numerals on this page. But if it was something, it was a test, and I need to decide if I need a Roman numeral or not, you need to look to see whether or not nickel has more than one oxidation state on the periodic table. So we find nickel, and it's right here. It's in a transition metal. It has more than one charge on the periodic table. Remember, you should have your reference tables out at the same time so you can refer to it. It's 2 plus 3. So I don't know what this one is. Is it plus 2 or is it plus 3? So then I need to use my negative charge, which is this oxygen being a negative 2. Let's make this a little bit bigger here. So then you can see it a little bit better, and it gives me more space to write. So then since since oxygen's a negative 2, then that means that this nickel must be a positive 2, because remember the sum of these oxidation states has to equal 0, because all compounds are electrically neutral. So since the charge of the nickel is positive 2, that means this is nickel Roman numeral 2 oxide. So let's do another example. So I'm going to name it just like I name other ones, right? The metal keeps its name. This is copper. Again, you'll use table S if you're not familiar with the symbols and the names. And then since that's a non-metal, I'm going to change the ending to "ide", so that's copper oxide. Copper lives in the transition metal neighborhood over here. It has more than one charge listed. So I need to figure out what charge is this copper in this chemical compound. So since oxygen is negative 2, right, you always know the negative charge. You have to go to the periodic table and get the negative charge, or table E if you have a polyatomic ion. And so since this is a negative 2, that means this copper must be the positive 2 to balance out this charge. So then that's a Roman numeral 2. So copper Roman numeral 2 oxide. And then again, sorry, you can put these in parentheses to make them look pretty and follow, protocol here. So now this is copper oxide. So the reason why we have these Roman numerals is because we cannot have two things have the same name. Every formula has to have its own unique name. So now I have a negative 2 for this oxygen. So since this oxygen's negative 2, this side of the molecule over here has to total up to positive 2. But I have 2 coppers that have to total up to positive 2. So each copper must be a plus 1, right? 2 positive 1s is equal to positive 2. So then this is copper Roman numeral 1, not oxides plural, sorry guys. Copper, and then this would be Roman numeral 1 oxide. And like we set up here in the notes, if you include the Roman numeral with the Roman numeral 1, it's okay, but you don't necessarily have to if it's a Roman numeral 1. So now I've got Cr, so this is chromium. And remember, you're using table S to help you with the names until you're very familiar with them, but always double check. And then this is bromine, so then that becomes bromide, right? Because that tells us, the ide tells us it's a chemical compound. And so now I check on the periodic table, find chromium. Where are you, chromium? Right there. It's in the transition metals, it has more than one charge, needs a Roman numeral. So I have to figure out the Roman numeral. So bromine is a -1, right? Because you have to have a positive, you have to have a negative. And we're only using the first negative charge for those nonmetals on the right-hand side of the staircase on the periodic table. So I have 2 of those -1s, so that's a total charge for bromine of -2. So if the whole bromine side is -2, that means my chromium side must balance that out and be a +2. And now I have a Roman numeral 2 as my, because remember, the Roman numeral tells you the charge of the metal. It is not the subscript of the metal. And so now let's go here. I have copper. I have more than 2 elements, so that means I'm going to go to table E, and I'm going to find this part on table E, and I'm going to name it just as it appears on table E. So that is sulfate. And now I check the periodic table, and where does copper live? Copper is right there in the center. It's a transition metal. It has more than one charge listed as its oxidation state on the periodic table, so that means I need to give this copper a Roman numeral. So I have to figure out what charge of copper combined in this 1-to-1 ratio with the sulfate. So I need the negative charge, which you're always given because it's on the periodic table or it's on table E. You always know the negative charge for sure. So if I have 1 sulfate as -2, that means that 1 copper must be +2, and that means that the Roman numeral 2 is going to be going along with copper, because that means that copper is a +2 oxidation state in this compound. Copper lost 2 electrons. Now let's look at this copper sulfate. So this is still copper sulfate. And now I know that my sulfate, this whole thing is negative, this whole sulfate thing is -2. So then my copper has to total up to +2. But I have 2 of those coppers. So if I have 2 coppers, the total charge has to be +2. So each individual copper is a +1. So then that would be our Roman numeral 1. And again, if it's Roman numeral 1, you don't have to include it. Not necessarily wrong if you don't. At least I wouldn't mark you wrong. At upper level, super upper level, maybe, but not for us. Okay, so now I have PB, and this is lead. Again, make sure you use table S. And then I have chlorine, so then that becomes chloride. And so now I find lead, and where are you? Lead, there it is. And it has more than one oxidation state, so it needs a Roman numeral. I'm not even going to look at what those oxidation states are on the periodic table, because those don't matter. I have to figure it out. So then I know that chlorine is a -1. And so if I have 2 chlorines, right, that means that both of these chlorines are equal to -2. So that means my lead over here must balance this overall -2 charge with a +2 charge. So then that means that the lead would be Roman numeral 2. So that's lead 2 chloride. Now let's look over here. I have Fe, according to table S, that is iron, and oxygen becomes oxide. And now I look at the periodic table. Iron has more than one oxidation state, so it needs a Roman numeral. My job is to figure out what the Roman numeral is using the negative charge from the periodic table for oxygen, which is -2. So sorry, every time I hover over here, that thing flashes. It drives me nuts. Okay, so I have 3 -2s. So that means the whole negative charge of this molecule is -6. So if I have iron, I have 2 of those that have to completely balance out that -6 to being a +6. So 2 times what number, which is going to be a +3, is going to equal our +6. And again, you could also reverse crisscross this here too, but I like to do this mathematically as much as I possibly can, because the reverse crisscross works most of the time, with the exception of here. Like if we look up here, so if this is a 1 and a 1, it's not copper Roman numeral 1 oxide because the oxygen was a -2. And then the same thing, the reverse crisscross works very well. It doesn't work very well with number 5, but it works very well with some other ones, right? So then the 2, if you're in doubt, the Roman numeral is going to be whatever the charge of the nonmetal is. Now let's go into and let's look at how do we go from the name to the formula. So I'm going to always use symbols, charges, crisscross, just like we did on page number 101, right? Symbols, right? Translate our words into symbols, grab the charges from the periodic table or table E, and then we're going to crisscross, right? Because that crisscross balances the charge, right? It's because it works because it's common multiple to cancel out the positive and the negative. So now let's go forth and let's do our work. The Roman numeral tells you that the charge of iron is positive. I don't need to look at the periodic table because the Roman numeral tells me. So then I'm going to write down Fe, and that has a +2 charge. Oxide means I have the element oxygen, so then that's going to be O. According to the periodic table, this is a -2. So I have a +2 and a -2. They cancel each other out. And then I always rewrite the formula without the charges on top, so it looks pretty. FeO. That's iron Roman numeral 2 oxide. So now I'm going to do tin bromide. I got to get the symbols. I'm not sure, tin, it's not Ti. Ti is titanium. Make sure you use table S. So tin is Sn, right? So some of the elements come from their Latin names. And now I have bromide, which tells me I have the element bromine, so Br. Now charges. This Roman numeral 2 tells me tin has a positive charge. Then I go to the periodic table, and so bromine's going to have a -1 charge. So I have a +2 and a -1. So now when I crisscross and I bring this 2 down, and then I just have 1 over here, and then that means SnBr2. So I have a +2 balances out the -2 on the other side. So now here I have vanadium Roman numeral 4, and then again, so that means that this is a +4. So V is 5, so then to the left means subtract 1, so 5 minus 1 is 4. And so now here's chloride, which is going to be chlorine, and periodic table tells me that's a -1 charge. So symbols V and Cl, grab our charges. The Roman numeral told me this is a +4. And the periodic table tells me -1. So crisscross, I'm going to bring the 4 down here, and then 1 for the vanadium, but we don't yet write the 1, so V and Cl4. Lead, Pb, and then chloride means Cl. Charges, this is telling me that this lead is +4. Chlorine is -1 from the periodic table, right? So +4, -1. So crisscross, right? I'm going to have a 4 and a 1. So I have a Pb and a Cl4. So now I have cobalt hydroxide. So even though this ends in "ide," it's hydroxide, not oxide. So this is going to be from table E. So my symbol for cobalt is Co, right? I used table S to figure that out. The Roman numeral 3 tells me this is a +3 charge, so cobalt is +3. Now hydroxide, I go to table E. Hydroxide is the OH, and it's a negative charge, -1 charge. So then I'm going to put that in parentheses, and I'm going to put that, there's my hydroxide, -1 charge, right? Symbols, charges. Now I crisscross. I'm going to take the 3, and I'm going to pull it on the outside of the parentheses, because I'm not just making 3 hydrogens. I need 3 of the hydroxides, and then 1 for the cobalt. So then that's a CO, and then an OH3. Careful with cobalt, right? You don't want to make sure, you want to make sure that you're not capitalizing that O, because that changes everything, right? Paying attention to the details. Now titanium, now that is Ti. This is Roman numeral 4, so that tells me that that titanium has a positive 4 charge. And then phosphide is the element phosphorus, which has a negative 3 charge on the periodic table. Phosphate, like this one, is from table E. They only really differ by 2 letters, so make sure you read very carefully, no skimming here. So then Ti and P, I have a positive 4 and I have a negative 3. So when I crisscross, I need 4 phosphorus and I need 3 of the titanium because I have a positive 12 now and a negative 12, and so the common multiple crisscross method is going to work just fine, right? So I have Ti3 and then P4. Okay, last but not least, so I have manganese, very carefully checking table S because manganese, and I'm just going to write this over here just because I feel like this is getting visually too much for my brain right now. Oops, I almost wrote magnesium, guys, because I was thinking about magnesium while I was saying how to check table S, right? So make sure you're extra careful. Manganese is Mn. This Roman numeral tells me that this manganese has a charge of 5 and then +1 +1. So that's positive 7 for the manganese. Phosphate means I'm going to go to table E and I have the PO4 phosphate from table E. This whole thing has a negative 3 charge. So then I'm going to put my phosphate in parentheses. So PO4. This whole thing has a negative 3 charge. My manganese has a positive 7 charge. So now when I crisscross, right, I'm going to take this 7, I'm going to put it on the outside of my phosphate group. I'm going to take this 3, and that's going to become the subscript of my manganese. And then I have an Mn subscript 3, and then I have my phosphate, PO4, and a 7. Right, so that wraps up page number 102. Keep practicing. My advice would be to have somebody write these down on a piece of paper, and you should go back and re-practice them and make sure that you're able to go from the formula to the name and the name to the formula. All right, until our next video, enjoy.